Good morning and good afternoon, RSGA STEM, and whoever decided to watch this video. And welcome to video number 7 on our series of STEM Around Us. Have you ever seen someone do something simple in the most complicated of ways? That's exactly what Rube Goldberg machines do. They're elaborate chain reaction devices that perform simple tasks through a series of crazy and complex steps. Today, we're going to see how everything we've learned from simple machines, forces, energy, and motion comes together in these amazing contraptions. And maybe later on in the year, we might design our own. We'll see how that goes. Who exactly was Rube Goldberg? Rube Goldberg was an American cartoonist in the early 1900s. He drew hilarious inventions. His cartoons showed ridiculously complicated machines that did everyday tasks in the most inefficient ways possible. Like a machine with 15 steps to scratch your back. Isn't that crazy? His name became so famous that we now call any overly complicated contraption a Rube Goldberg machine. Here's the thing. They're not just funny, they're brilliant demonstrations of physics and engineering. Every Rube Goldberg machine is actually a chain of energy transformations and force interactions. Maybe a marble rolls down a ramp. Potential energy becomes kinetic. It hits a domino. That's force transferring through collision. The dominoes knock over a lever that releases a spring, stored elastic energy. The spring launches a ball that pulls a string, more force and motion. Every single step uses science contraptions that we've studied. It's physics in action. If you look closely at any Rube Goldberg machine, you'll find simple machines everywhere. Levers that tip and tilt, pulleys that lift weights, inclined planes that guide balls or something that rolls. Wheels roll and turn. Screws and springs store energy. Even though the overall machine is complex, it's built on the same 6 simple machines that we've used for thousands of years. That's the beauty of engineering. Complex solutions from simple machines. You might think Rube Goldberg machines are just toys. Think of the game Mousetrap. It was just a game that you built as a toy to catch a mouse. But the principles are really serious. Modern assembly lines are basically controlled chain reactions. One step triggers the next. Automated warehouses use complex systems of conveyors, robots, and sensors all working in sequence. Even car manufacturing uses elaborate systems where each station completes one task, then triggers the next task. Industries call this automation, but it's really just a practical Rube Goldberg machine. Rube Goldberg machines follow key principles. First, they need to be reliable. Every step must work consistently. Second, they must transfer energy. Every step must have enough energy to trigger the next step. Timing. Well, yeah, that's important because steps must happen in the proper sequence. Then there's safety. It can't have anything dangerous or out of control. And finally, they need to be creative. The more unexpected and clever your solutions, well, the better. Engineers use the same principles when designing any automated system. Let's look at some popular mechanisms used in these machines. Domino chains for sequential motion, maybe ramps for controlled rolling, seesaws and levers for direction changes, pulleys for lifting, mousetrap springs for stored energy, springs and pendulums for timing, falling objects for dropping force, string pulls for distant triggers. You can even combine these in endless ways. Each mechanism is simple, but together they create something amazing. Rube Goldberg machines also teaches us something about the engineering design process. Remember, in engineering, we must first define the problem, or decide what the problem is. It's a simple task. What do you want the machine to do? Second, you've got to figure out or brainstorm solutions. What steps might work? Third, you've got to create a plan. Maybe you sketch your design or draw something out. Fourth, you build the prototype, right? It's the first initial concept. Fifth, and this is the most important, you test and fail, and then make improvements. Your machine probably won't work perfectly the first time. So again, you've got to iterate, which is those improvements that you now integrate into the design. It's exactly how real engineers work on actual problems. If you love the idea of designing complex systems, there are incredible careers waiting for you. Robotics engineers design robots that perform tasks autonomously, basically by themselves, right? They're basically mobile Rube Goldberg machines. Industrial engineers optimize manufacturing processes and assembly lines. Automation specialists program machines and systems in factories and warehouses. Even theme park designers create elaborate ride experiences that are so carefully orchestrated they appear just to be a sequence of events. Creative activities plus engineering equals, well, an amazing, amazing career. And this brings us to the end of this particular video, and we have one more video in our series. We're going to get a further glimpse at different careers in STEM.